This video goes over some of the properties of polynomial functions that you'll need to know to graph them and to solve problems. So in order to graph a polynomial function, the first thing you need to know is the zeros. That's where the function crosses the x-axis. You could also think of it as solving the polynomial equation by setting it equal to 0, and then you can use factoring, the quadratic formula, long division, or the factor theorem, which we'll learn about later, in order to put it in factored form to be able to identify those zeros. The next thing that you need to know is the degree, if it is odd or if it is even. Odd functions finish in opposite directions, so they either go up to the right and down to the left, or down to the right and up to the left. Even functions finish in the same direction, so they either both finish down or both finish up. The next characteristic is the sign of the leading coefficient. The sign of the leading coefficient can be positive or negative. Functions that have a positive leading coefficient, for odd functions, they finish up to the right, or even functions, they both finish going up. For negative leading coefficients, they would go down to the right, or they would both finish going down. The next characteristic is a turning point. This is where a function changes from increasing to decreasing or the other way around. The maximum number of turning points that you can have is the degree minus 1. So if you have a first degree function, this is a linear function, and the maximum number of turning points would be your degree minus 1 would be 0, which makes sense. A line doesn't change direction at any point. If you have a degree 2 function, that would be a quadratic. Maximum number of turning points would be 2 minus 1, which is 1. Makes sense. A parabola changes direction one time at the vertex. A degree 3 function is a cubic. Maximum number of turning points would be 3 minus 1, which is 2. If you don't know what a cubic looks like, it sort of looks like a snake, like this, changing direction up to a maximum of 2 times. A degree 4 function is called a quartic function. Maximum number of turning points is 4 minus 1, which is 3. And a quartic function kind of looks like a W, which has the 3 points where it changes direction, or up to 3 points. Okay, so if you have an nth degree function, your maximum number of turning points is n minus 1, as we said above. We also need to know the end behaviors of a function. This is our 5th characteristic. We've got 4 different categories. We've got odd and positive. So odd, we know, finishes in opposite directions. Positive, we know, is going up to the right. Odd and negative is going down to the right. Even and positive is going up on both sides of the y-axis. And even negative is going down on both sides of the y-axis. The last criteria that you need to know for sketching is called the multiplicity, or the order of zeros. This describes how the function behaves when it crosses the x-axis. So something with an order of 1 would be a factor that looks like this. This crosses the x-axis just like a line would. It goes straight through at the value of the 0 that's indicated in the factor. 0 with order 2 would be something with an exponent of 2. At that 0, the function is going to behave like a parabola, so it touches the x-axis but doesn't cross. Order 3, that is an odd degree. just like the first degree, it crosses through the axis again. But this time, instead of going behaving like a line, it's going to behave like a cubic function. And as it approaches, it sort of wiggles a little bit as it goes through. Multiplicity 4 would be a function that looks like this, where its factor is raised to the power of 4. So still, the point of interest is at x equals -1, but this time it behaves like a quartic and touches the axis but does not cross. Okay, order 5, much harder to draw, but for our purposes, we just need to show that it wiggles as it goes through. Odd roots with odd multiplicities cross through the x-axis. Roots with even multiplicities touch the x-axis. So just to wrap up, for example, here we're going to determine the end behavior, the sign of the leading coefficient, and the zeros. So in order to do that, I'm going to look at the very beginning, and I'm going to see that there's a positive value there. So that means that my leading coefficient is positive. And the degree of my function, I'll use a d for that, is 2 because I've got 2 factors there. So my end behaviors are even, positive, which I can show by drawing this. They both finish going up. And then the only other thing I need to figure out are the zeros. I'll write those over here. This you should be used to doing from grade 10. We've got x equals -1 and x equals 3. For the second one, I still have 2 factors. I noticed right at the beginning I've got a negative sign, so that means that my leading coefficient is negative. My degree is 3 this time because I've got 1 x from the first bracket and 2 x's from the second bracket, which gives me a total of 3. That means that my end behaviors are odd, negative. I can look back at the chart that we did in an earlier slide, and I know that odd, negative goes down to the right, kind of like a line with a negative slope. And then the last thing that I need to state are the zeros, which come from the factors, which in this case would be x equals -1 and x equals +1. For future reference, that second zero has a multiplicity of 2, so that means that it would touch the x-axis. The first zero has a multiplicity of 1, so that means that it would cross the x-axis. So those are some key things that you need to know about characteristics of polynomial functions.